In this section, we're going to discuss the idea of wrappers. Java numeric primitives are fast for the machine because they are exactly represented in memory and handled by the CPU. Any object that uses a value that doesn't directly translate to one of these primitives that the CPU handles has to be converted. Values must be changed from the way they're represented conceptually and in memory to one of these primitive types. This conversion takes time, obviously, because the moving of bytes and bits around takes time and a certain amount of complexity. However, using primitives, although faster, are more complicated to programmers, are more effective at using symbolic views of data, and objects represent those symbolic views much better. The conversion to primitives becomes costly to programmers. Not only does it read more awkwardly in many cases, extra code has to be written to do the conversion, and one must remember to do that conversion and reconvert it when finished. This takes time and precision on the programmer's part. A later addition to the language is the idea of a wrapper. It is a class that represents each of these primitive types. The corresponding class is named the same as the primitive type, but with a leading capital letter. One exception is the primitive int type. Its wrapper class is integer, capital I, integer. Wrappers provide various definitions and behaviors that make conversions in a program much more simple. And in fact, the compiler will automatically convert in a number of cases, as will be discussed in the next section. A data type has a minimum and maximum representable value. Given a fixed number of bits, only a certain number of patterns can be possible. Within these possible patterns, there is a minimum and a maximum value. Rather than memorizing or looking these values up, wrappers define them. Each data type has a min value and a max value defined that can be used. They are constants and can be compared against in any other numeric operation. For example, integer.max value is the maximum representable integer value. It's about 2.14 billion, or double min value, which is something around -2 times 10 to the minus 308th power. Any value that falls between the min and the max is a legitimate pattern that we can represent a number. Outside of that, the data types cannot represent any value. Wrappers supply a number of conversion methods which convert the object's actual value to some other primitive type. An example here is we create an integer, I, assign it the primitive literal value 42. It objectifies that and creates an object containing the value 42. And in the second line of code, we say I.double_value, which means convert the integer to a double value. So D, a primitive, will be assigned to the value 42.0. Some of these data conversions will truncate data, just like casting does with the primitive type. So do be cautious when converting a larger type to a smaller type. You may lose data. Often we find that numeric values are represented as strings. Often this is true in spreadsheets, databases, etc., where strings are more easily representable of the data because they are literal characters that a human can read. However, as strings, they are not in their final numeric form. They must be converted. The wrapper types provide a certain number of parsing methods that will convert strings to the object with a value that represents that string literal. For example, here, string S assigned 42. That's the character sequence 42 representing a string. Integer.parseInt S says take that string and parse it into an integer value. Obviously, if there are characters involved in that string that are not consistent with an integer, an exception will be thrown. But here we see N will have the numeric value 42.